Hi, Algebra 2 students. This is Lesson 8, Polynomials, Graphing Linear Equations, and Intercept Slope Method. First, polynomials on the bottom of page 50. Polynomial is a simple kind of algebraic expression. It has a coefficient that is a real number and variables that have a whole number as exponents. That just means that you can't have a negative exponent or a fractional exponent. A polynomial could be written as like a -4, or it could be a 1/2, or it could be 2x, or it could be a -3x squared. Those are all polynomials. This is a polynomial because even though it's negative and you don't see an x, we could write it as x to the 0 power, and this equals 1, so it doesn't change the value of this, so this is still a polynomial. Same with this 1/2. This x has a 1 as an exponent, so that's a whole number. So these are all polynomials. You can have a fraction or a decimal, but you can't have a fraction or a decimal or a negative in the exponent, not the coefficient. The coefficient's fine to have that. If you have just one of these, it's a monomial. If you have two of these, then it's a binomial. If you have three of these, it's a trinomial. Like expression like this. Okay, this is a trinomial, a polynomial equation. It is a trinomial because it has three terms, and all of these polynomials have just a 1 in their exponent, so it's a first degree polynomial equation. Well, a first degree polynomial equation like this is a straight line. So in order to graph a straight line, which is what we're going to do, we would first need to put this into, we need to solve it for y. And so we would move 2x to the other side. And then we would divide each of the terms by that coefficient of y, which is 3. Okay, now this is in slope-intercept form. And the parts of this are, this is the slope, and this is the y-intercept. Okay, and you will often see this equation when you talk about a line, y equals mx plus b, where m is the slope and b is the y-intercept. Okay, once we have our equation, we can make a table, an XY table, and we can put numbers in for X and get a value out for Y into this equation. So if we use 0, 6, and -6, well, when we put 0 in for X here, then this is going to equal 2, right? When we put 6 in, oops, I just did. Back up. When I put in 0 for x here, 0 times -2/3 is 0, plus 2 is 2. Then when I put in a 6 for this cancels with this. So this would be a -2 times 2, which is -4 plus 2, which equals -2. And then when I put in a -6, it changes the sign. This still cancels. This is still 2, but it's a negative 2 times a negative 2. So this is a positive 4 plus 2. So this is a positive 6. So when I graph that on my um, when I graph that onto my coordinate plane, it's the x-axis is left and right, the y-axis is up and down. I would go 0 to the right or left and go up 2. And then I would go, my next one, it graphs 6 to the right, 1, 2, 3, 4, 5, 6, and down 2. And my third one graphs 6 to the left, 1, 2, 3, 4, 5, 6, and up 6, 1, 2, 3, 4, 5, 6. And there's my straight line. Okay, turn the page. Now, if you look at the intercept slope method, you could take that same equation, solve it for y. Y equals negative 2/3 x plus 2. And you can graph it without going through and putting in substituting numbers in for x by just using what you know about the y-intercept and what you know about the slope. So the y-intercept means that when x is 0, y is whatever is here. So that means that our first point is going to be up 2. Now, when we use the slope to graph, we start with that y-intercept, we graph that point, and then we use the rise over the run to graph the next point. So the rise is up and down, vertical. The run is horizontal. So my rise, I could use a negative 2. So I'm going to go up 2, 1, 2. And then I'm going to go, if I go, I'm sorry, I'm using a negative 2. So I'm going to go down 2, 1, 2. And then I would go to the right 3, 1, 2, 3. If I use a negative 2 over 3, positive 3. And I could do that again. I can go down 2, 1, 2, and to the right 3. Okay, that is one line. I can also use this as a positive 2 and a negative 3, because what matters is whether this fraction is positive or negative, not whether you use the negative in the numerator or the denominator. So if I use that positive 2 from the y-intercept right here, I would go up 2 and to the left 3. And you see how that's on the same line. Okay, let's look at 8-3. Same thing. We've got y equals a negative 3x minus 3. Well, this negative 3x, your slope, we would want to write that as a fraction. So that would be negative 3 over 1. And remember, we can use it as negative 3 over 1 or positive 3 over negative 1. And then our y-intercept is negative 3. So on my coordinate plane, I would graph my y-intercept first. So it's negative 3, so it's down 3 places. 1, 2, 3. And from there, I would use my slope. So I'll use negative 3 over 1. So my rise is going to be down 3, 1, 2, 3, and then to the right 1. Down 3, and to the right 1. Now I'm going to use my other slope. I'm going to use positive 3, negative 1. Up 3, over 1. Up 3, over 1. And you see how all of those points are on the same line. Okay, turn the page to 54. And why don't you try to use the intercept slope method to graph 3x plus 4y equals 12. Step 1 is to take this 3x plus 4y equals 12 and solve it for y. Okay, pause for a minute and then come back and see how you do. All right, I'm solving this for y, so I'm going to subtract 3x from both sides. That leaves me with 4y equals, and I'm going to put that negative 3x first because that's in slope-intercept form. I'm going to divide each side by 4, and y is going to equal a negative 3/4 x plus 3. Okay, now I'm going to pull out my coordinate plane. And I'm going to first graph my y-intercept up 3, 1, 2, 3. And then I'm going to go to the left. I'm going to go down 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Because I've got a negative 3 rise and a positive run. 1, 2, 3, 1, 2, 3, 4. Now, if I wanted to switch that up, I can do a positive rise and a negative run. So from that y-intercept, I'm going to go up 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. And you see that's on the same line. Okay, I hope that helps. Thanks.